Okay, consider a steam power plant operating on the simple ideal Rankine cycle. Steam enters the turbine at 3 megapascals and 350 degrees Celsius and is condensed in the condenser at the pressure of 75 kilopascals. Determine the thermal efficiency of this cycle. So, yung sa gilid, meron akong schematic diagram. So, this is yung boiler natin. Ito yung boiler natin. Operating at P is equal to C. Then, papasok yung ating heat. Then, point 1, after the boiler, we have from the problem, no? Pressure 1, 3 megapascal and temperature 1 of 350 degrees Celsius. Then at S is equal to C, ito po, dito papasok yung steam natin sa turbina, then lalabas sa point 2. Then, yung ating turbina, mag-generate yan ng pinatawag natin work ng turbine. Then, at point 2, papasok yung ating steam. Pasok yung ating steam sa condenser. Then, magkakaroon na heat rejection. Okay? Then, this is operating at P is equal to C. Then, lalabas steam at point 3. Papasok sa pump at S is equal to C. Of course, merong work ng pump. And then, lalabas si steam at point 4. Then, pasok ulit sa ating boiler. Okay? So, we have the following given. Okay, so we have steam enters the turbine, point 1 yan, no? Papasok sa turbina. So we have P1 of 3 megapascals and P1 of 350 degrees Celsius. And then the pressure at the condenser. So we have P sa condenser. Dito raw, pressure dito, which is equal to 75 kilopascals. Nagkataon, at this points, point 2 and point 3, then dito, yan ay P is equal to C. So therefore, this is equal to pressure 2, equal na rin to sa pressure 3, which is 75 kilopascal. So, i-convert ko na dito, no? So we have 1,000 kilopascals for every 1 megapascal. So you have 0.075 megapascal. Bakit ko ginawa megapascal? Kasi yung gagamitin kong values are taken from steam tables by Keenan and Keys SI version. And yung pressure doon is in megapascal. So, para mas madali na lang makita. Then, afterwards, the problem requires us to find the cycle thermal efficiency. So, solution. So, hindi naman tayo agad makakapag-solve. Kailangan muna natin hanapin yung values ng mga points, no? Ng enthalpy. Okay. At point 1, we have pressure 1 is equal to 3 megapascals. And then we have P1 of 350 degrees Celsius. Okay? So, let na lang natin let P1 be your P saturation at point 1. So therefore, this is 3 megapascal. So kukuha tayo ng values, no, sa steam tables. And then I have P1 is equal to P actual at 1, which is equal to 350 degrees Celsius. So by the way, this is also equals to P actual kasi in reality, P actual naman talaga siya, no? So i-check kasi natin yung condition ng steam at point 1 using the values found in the steam table at 1. Okay? So from table 2, okay, at PSAT, which is equal to 3 megapascal. So meron kayo makikita ng 3 megapascal doon. Yung katapat niya, PSAT at P is equal to at 3 megapascal, nakalagay ay 233.9 degrees Celsius lamang. So, check natin ang condition. Check condition of the steep. Since T1 is greater than T saturation at pressure 1, therefore, it is a superheated vapor. So, ideally naman talaga, no, dapat superheated vapor yung ating point 1. Now, kapag superheated vapor siya, proceed tayo sa appropriate table para kunin yung value. So, saan table yon? So, proceed tayo sa table 3. So, from table 3, so we have at P1 of 350 degrees Celsius, and then T1, sorry, this is T1. T1, okay, ayusin natin. So at T1 of 3 megapascals and T1, which is 350 degrees Celsius. So check mo, meron ba daw steam tables, table 3, no? Na merong 3 megapascal at saka 350. So meron kang makikita. So kunin ko yung value ng H and S. So you have enthalpy 1 is 3,115.3 kilojoules per kilogram Kelvin. And then, of course, specific enthalpy at point 1, according to the table, is 6.7428 kilojoules per kilogram Kelvin. Correction, walang Kelvin to. Okay. So, yan na yung values natin for point 1. Then, proceed tayo at point 2. So, at point 2, okay. So, ano ang masasabi natin at point 2? At point 2, di ba, meron tayong turbina, heavy system natin. So, masasabi natin na S1 is equal to S2. So, yung nakuha natin value ng S sa point 1 equal lang sa value ng S sa point 2. At the same time, no, since P is equal to ito, we can say that P2 is equal to P3. So, meron na tayong dalawang points, S at saka P. Okay? So, I have P2, which is equal sa P ng condenser, that is 0.075 megapascals. And then I have S2, which is equal to S1 na 6.7428 kilojoules per kilogram Kelvin. Box natin to para hindi na nakalito. Okay. So again, check natin ang condition. So let natin, let your P2, which is yung ating P actual, no? At point 2, P equal to your PSAT at point 2. So this is 0.075 megapascals. And then I have S2, which is equal to S actual at point 2 with a value of 6.7428 kilojoules per kilogram Kelvin. Okay. So gamitin ko na lang table 2. From table 2, okay. So from table 2, so at P sat of 0.075 megapascals, meron tayong PSAT, no? PSAT at P, which is equal to 91.78. According sa table ito ha, 91.78 degrees Celsius. So, gamitin natin yung specific entropy as a point or thermodynamic property para malaman natin yung condition ng steam, no? So yung reference sa thermodynamic property. So since S to, kukunin ko sa S sub F. That is specific entropy at what? At saturated liquid condition. So SF2, that is SF at P sub. So that is equal to what? For this table, we have 1.2130 kilojoules per kilogram Kelvin. And then I have S sub G2, which is specific entropy at saturated vapor condition. That is SG at PSAT. So ang value po niya is 7.4564 kilojoules per kilogram Kelvin. And then, check natin ito, tsaka ito, no? So, check natin ang condition. Pagkumparahin natin yung tatlong values. So, check condition. So, since ano masasabi natin? S sub F2 is less than S2 is less than SG2. Therefore, it is a wet vapor mixture. So, at point 2, ito pala ay wet vapor mixture. So, kapag ideal naman talaga, wet vapor, no? So, since wet vapor mixture siya, meron siyang quality na tinatawag, no? Yung amount o yung fraction ng vapor sa buong system at point 2. So, hahanapin natin yan. So, for quality X, for X sub 2, so kukunin natin sa entropy ulit. So, property na wet vapor mixture, so you have S sub 2 is equal to S sub F2 plus X sub 2, S sub FG2. Okay. So, since meron na akong SF tsaka SG, yun na lang gagamitin ko since S sub FG is equal to SG minus SF. So, we have X sub 2 is equal to S sub F2 plus X sub 2 times SG minus S sub F. So, ito ay lahat sa point 2. So, therefore, quality 2 is equal to S sub 2 minus S sub F2 over SG2 minus S sub F2. So, we have S2 of S2, we have 6.7428 minus S sub F2, 1.2130, or divided by SG2, 7.4564 minus 1.2130. So, meron akong quality na ilan? So, we have X of, according sa calculator, 0.8857033 027 or 88.57033027%. Okay. So to find enthalpy 2, H lang naman ang kailangan natin at point 2. So for H2, again, property ng wet vapor mixture, we have H2 is equal to HF2 plus X sub 2 times HFG at point 2. So, saan natin kukunin? So, from table 2, okay, at P of 0.075 megapascals, ang kukuha natin si HF, no? HF2, that is HF at PSAT na yan. PSAT ito, no? Which is 384. 384.39. kilojoules per kilogram. And then we have Hg2, that is Hg at Psat at point 2 to, Psat at point 2, Psat at point 2. Iwanagin lang natin. So this is 2278.6 kilojoules per kilogram. So we have H2 is equal to 384.39 plus X2. O ito, na-complete natin kanina, 0.887033027 times HFG. HFG to, hindi pala HG, no, correction. HFG2. So that is 2278.6. So calculating that, we will be having H2 of 2,402.6 kilojoules per kilogram. So ito yung kailangan natin dyan. Next, at point 3, no? So at point 3, kailangan natin, ano makukuha natin value? Ito, no? From the given. Kasi P2 is equal to P3. So we have P3, which is equal to P2.075 megapascals. And then, we can say that S3 is equal to S4. However, wala pa tayong value niyan. Ideally, ang condition ng point 3 is saturated liquid. O, ayun ha. Tandaan nyo. So, ito. Saturated liquid yan. Pag hindi binigay. So, thus, no? So, P3 is equal to PSAT, no? PSAT, which is equal to 0.075 megapascal. So, yung from table 2 again, okay? So, we have at P3, which is equal to PSAT at 0.75 megapascal, may makukuha kayong value ng T sub 3. T sub 3, pag saturated liquid, equal lang sa Tsat at Tsat at 0.3, no? Which is equal again to 91.78 degrees Celsius. And then, ang kailangan natin dito is in H at saka V, no? So, H3, automatically, pag saturated liquid, that is H sub F, no? Yung may subscript, no? Na F. So, HF at P sat 3 or HF at P3. So, according sa table, at ginamit din natin kanina, that is 384.39 kilojoules per kilogram. And then we have V sub 3, that is V sub F at P sat sa 0.3. So, that is V sub F at P3. So according sa table, that is 1.0373. Of course, pag kalimutan ng times 10 raised to negative 3 cubic meter per kilogram mass. So ito na yung mga kailangan nating values sa saan? Sa point 3. Now, at point 4, so yan ay meron tayong pressure, no? P4 is equal to P1. That is equal to 3 megapascals. And then we have S4 is equal to S3. So, kunin natin yung S3 na rin para ma-check natin yung condition. S3 is S sub F at P sa point 3. So, this is S sub F at P3. So, that is equal to, according sa table, 1.2130 kilojoules per kilogram Kelvin. So, this is 1.2130 kilojoules per kilogram Kelvin. So, let natin yung P4, that is PSAT at 0.4. Pero in reality, that is your P actual at 0.4. That is 3 megapascals. And then we have S4, that is your S actual at 0.4. So 1.2130 kilojoules per kilogram Kelvin. Okay? So from table 2 at P4, which is 3 megapascals, meron tayong PSAT, no? O ito yung PSAT. PSAT at 4. Meron tayong PSAT at P4. PSAT at 4. That is 233.9 degrees Celsius, no? And then, meron ako, since S to, pang compare natin, kunin ko si S sub F at 0.4. That is SF at P, no? Na 3 megapascal, which is equal to 2.6457. 2.6457 kilojoules per kilogram Kelvin. And then SG at 0.4, that is SG at 3 megapascal. So according sa table, that is 6.1869 kilojoules per kilogram Kelvin. So compare natin ito, tsaka ito. So check condition. Ano masasabi natin? Since yung ating actual na S4 is less than S sub F4, so therefore it is a compressed liquid. So kung compressed liquid yan, compressed liquid to. S4 is equal to S3. So IP1 equals P2. IP4, sorry. Okay, so kung yun ay compressed liquid, po-proceed tayo sa table 4. And kung makikita nyo sa table, no, wala agad yung value. So mag-i-interpolate pa tayo. And to be exact, magdo-double interpolate pa. So masyadong mahaba. Gamit na lang tayo ng ating approximate formula for enthalpy. So using the approximate formula, so we have H4 is equal to what? Is equal to H3 plus V sub 3 times P4 minus P sub 3. O doon pala yun, no? So we have H4. O meron na tayo nakuha kanina H3. So H3 natin is 384.39. Okay, so this is 384.39 kilojoules per kilogram plus V sub 3. V sub 3 natin is 1.0373 times 10 raised to negative 3 cubic meter per kilogram mass times P4. Ang P4 po natin is 3 minus P3 natin ay 0.075. Yan po ay naka-mega pascals. So convert natin itong part na to. So times 1 megapascal for every 1,000 kilonewton per square meter. So yan ay kilopascals, no? Okay? So, cancel ito. Okay? Cancel ito. May matitirang isang meter dito. Cancel na to. So, ang magiging unit natin is kilonewton meter. Kilonewton meter per kilogram. So, matitirang unit natin is 1 kilonewton meter per kilogram, which is equal to 1 kilojoules per kilogram. Cancel mo na yan. Cancel ko na rin to. Ito matitirang yun. So, parehas na. No? Pwede mo na siyang i-add or i-calculate using calculator. So, H4 is 387.96 kilojoules per kilogram. So, ayan po yung ating kailangan na values. Okay? So, try nating i-drawing sa TS diagram yung mga values, TS and HS diagram. So, dito na lang. So, for the HS or Moliere no, diagram, of course, hindi ito accurate. No? So, HS, okay? So, meron akong pressure line. O, ayan. Ayan. So, let's say, ito yung mataas sa pressure. P1, which is equal to P4. That is 3 megapascals. And then, this is yung P2, which is equal to P3. Which is pressure sa condenser na 0.075 megapascal. Okay? Next. At point 1, ang given ay H tsaka T. So, lagyan natin na ito yung T. Okay? Ito siya mag-intersect T1 of 350 degrees Celsius. So, this is point 1. Point 1. Yan, point 1 yan, no? H to, by the way, and then this is S. And then, mag-expand siya, no? Okay? So, from point 1 to point 2 at S is equal to C. So, gawa kang vertical line. Yan. Yan ay S is equal to C. This is your point 2. Project lang natin pababa. So, we have S1 is equal to S2 na 6.7428 kilojoules per kilogram Kelvin. Okay, so yan ang ating point 2. So, tama naman, siya ay wet vapor mixture. And then, magpapasok siya sa condenser, yung steam natin. At P is equal to C. So, susundan natin itong pressure line na to. Ayan. So, this is P is equal to C. Then, ang condition niya is saturated liquid. O, ayan. And then, ano mangyari? Papasok siya sa pump, yung steam natin. And then, tataas yung pressure niya. Babalik dito. So, ayan. At S is equal to C. So, ibig sabihin, S3 is equal to S4. At ang condition ng point 4 ay compressed liquid. Okay, so tama naman. And then, at point 4, pasok sa boiler, balik sa point 1. Okay. So, yan yung ating HS diagram. For TS diagram naman, so ating TS diagram, okay. So, ito yung ating saturation curve. Ayan. So, meron tayong pressure line. Dalawa. Okay. So, ito yung isobar natin. So, this is pressure for the higher one, P1 is equal to P4. That is yung pressure din na actually ng boiler, no? Kalimutan ko sabihin, that is 3 megapascals. And then we have P2 is equal to P3. Pressure ng condenser, which is equal to 0.075 megapascal. And then at point 1, no, meron tayong given na pressure. Ito, 3 megapascal and then temperature. O, project na lang natin. So itong aking point 1, superheated siya, no? So we have P1 of 350 degrees Celsius. Then, ano mangyayari? At S is equal to C. Ayan. Magiging wet vapor siya. 0.2. So this is S is equal to C from 1 to 2. So this is S1 is equal to S2. By the way, y-axis is T, x-axis is specific entropy. S1 is equal to S2. Then, papasok si steam sa condenser. Okay? Kakaroon ng heat rejection. Sundan mo lang yung isobar na yan. Then, magiging saturated liquid siya. At P is equal to C. Then finally, pasok si steam sa pump. Mag-increase ang pressure. At S is equal to C. So S3 is equal to S4. And then, at point 4, pasok si steam, pabalik sa boiler, then labas sa boiler. So, yan. At P is equal to C. So, yan po ang ating TS diagram. So, kung gusto niyo pang i-plot yung H, pwede naman. Okay. So, kung ipoproject ko dito, ito ang aking H1. Ito ang aking H4. Ito ang aking H3. Then, H2, no? Ito yung aking H2. So, hindi naman siya per scale, no? Basta yan yung rough TS and HS diagram. Now, proceed na tayo sa hinahanap sa wakas, no? Pwede na tayo mag-solve. So, yung required talaga is yung ating thermal cycle efficiency. Okay? So, E sub Tc is equal to the work net over energy chargeable, which is yung QA. Okay? Nasaan ba yung work net dyan? So, kung ito ang TS diagram natin, okay? Dito pasok si QA. Tama? Labas dito si work ng turbina. Pasok dito si work ng pump. And then, work ng pump. Dito pala yan. Pasok dito si work ng pump. And then, dito is labas, no? Lalabas si QR. So, heat rejected. Nasaan si work dyan? O, ito po. Yung area dito. O, yung part na yan, yan yung ating work net. So, mabalik tayo sa solving natin. We have work net, pwede siyang QA minus QR or over QA, or pwede rin work ng turbina minus work ng pump over QA. Okay? So, ito na lang gamitin ko. So, E sub TC. So, work ng turbina, ayan, di ba? Ito yun, dito. So, that is H1 minus H 2. So, work ng turbina is mass of steam times H1 minus H2. Minus work ng pump, no? Work ng pump is H4. Ayan, mas mataas yung 4. H4 minus H3. So, that is mass of steam times H4 minus H3 all over QA natin. Ito, right minus left. So H1 minus H4. MS H1 minus H4. So cancel na natin to. And then, makakuha na natin again yung formula. Diba sabi ko alternating lang yan. H1 minus H2 plus H3 minus H4 over H1 minus H4. Substitute natin yung values ng mga nakuha natin. We have H1 of 3115.3 minus H2 2402.6 plus H3 384.39 minus H4 387.42 all over 3115.3 minus 387.42. So, makancel na yung unit sa taas at sa baba. Parehas lang naman. So, finally, you have cycle thermal efficiency of 0.260154, 4056, or 26.01544056%. So, ito po ang sagot. So, mga around 20+% lang yan pag Rankine cycle kasi mababa talaga siya. So, may mga ginagawa para mapataas yung efficiency ng Rankine cycle.